Hey guys, in this video we're going to look at how one would determine the molar mass of molecules, that is, structures containing two or more atoms combined together, or compounds, so substances that consist of two or more different elements. So hopefully you've watched a video on what which introduces molar mass, and you know what molar mass is, and you can work it out for individual elements. Now with molecules and compounds it gets a little bit trickier. Firstly, you need to be able to read chemical formulae. You need to be able to interpret chemical formulae. So if you are given chemical formulae such as this, you should be able to quickly identify that there are two different elements, and you should know how many of each element there are. Now if you don't know that Fe2O3 means that you have two iron atoms combined with 3 oxygen atoms, then you need to watch another video which talks about how one would interpret chemical formulae, and so that'll be linked in the description for this video. But if you can do this, then you're one step towards being able to work out the molar mass for these compounds here. Okay, so where to get started? Well, first let's have a look at the first learning goal. It's important to be able to correctly write out your calculations. You correctly represent different things when doing these calculations. So the way that we represent molar mass, now molar mass is usually denoted, that is written out as M, capital M, with a subscripted capital R. This is molar mass. So when you want to work out the molar mass of, say, let's just do it for a single element, so molar mass of nitrogen, you would go this capital M subscripted R, and then you open brackets. You put nitrogen inside brackets, so you close the bracket with nitrogen inside, and that denotes, this here denotes molar mass of a nitrogen atom, because inside the brackets, which is what is being specified or given, inside the brackets it is what we are working out the molar mass for. So I'll rephrase that. We are working out the molar mass, the MR, of whatever is inside the brackets. And so nitrogen, if you look at the periodic table, its molar mass is 14.007. So we'd go 14.007 grams per mole. So I'll write it this way, grams per mole. Okay. Now if we're going to denote the molar mass of iron oxide up here, we would go MR Fe2O3. And so the MR again represents molar mass, and in the brackets is the specified substance. So writing this out means molar mass of iron 3 oxide. Okay, so we can denote that. Great, but how do we work out the molar mass of iron oxide? Okay, so you would know how to work out the molar mass for a single element. So we'll start there. We have to work out what the molar masses for these guys are, both iron and oxygen. So you go to our periodic table, and we find out iron's molar mass is 55.845, and oxygen's molar mass is 15.999. So these are both in grams per mole. Okay. Now the chemical formula tells us that there are two iron atoms and 3 oxygen atoms. So we need to take this into account. If we have more than one of each atom, we have to multiply this into this value here that we know, it tells us the mass of 1 mole of iron. But we have 2 iron atoms, so we have to consider that a mole of iron oxide will actually have, I'm going to write this down, 1 mole of iron oxide has 2 moles of iron and 3 moles of oxygen. And I want you to seriously consider this, and if this is a really important point. When you have 1 mole of this kind of substance, where there are multiples of different elements, the moles of the elements themselves actually change. Okay, so see if you can think this through. If you can't, make sure that this is on your questions list. Something to ask me to clarify. Now, because we have 2 iron atoms, we need to multiply then the molar mass of iron by 2. Okay, and then we combine that with the combined molar mass of all the oxygen atoms here. So we write this out. I'm not going to put in the units yet until I finish the final calculations. I'm going to get my calculator and quickly work out this value. Okay, so I'll plug this into my calculator, and my calculator tells me that the total for that for the above is 159.687 grams per mole. And that's how much a mole of iron oxide weighs. Okay, this is the mass of that we would find in a mole of iron oxide. Alright, so just a couple of more examples. How about we work out the molar mass of water, we work out the molar mass of carbon dioxide, and the molar mass of glucose. Alright. So feel free to pause the video and find out the answers for these. I will give the answers at the end, just in a bit. So just rounding up, the molar mass of water is about 18 grams per mole. You might have more or less decimal places. The molar mass of carbon dioxide is 44 grams per mole, and the molar mass of glucose is about 180 grams per mole. So if you got these values, fantastic. You probably know what you're doing with working out these molar masses. So there will be more practice to be done in class. But I hope this video helped. Thanks for watching, guys.